Well, you, like most of us, rely on our smartphones for just about everything, right? Now, imagine using it to test for COVID, for HIV, or even TB. It seems like something futuristic out of a Hollywood movie, don't you think? Well, it's actually not. The CSIR is spearheading a new technology like this, and they want people in even the most rural parts of Africa to be able to access life-saving technologies. So let's get more from the CSIR's Dr. Mthunzi-Kufa just to understand exactly what this new technology is all about. Doc, thank you for your time, and good morning to you. This is quite fascinating, I have to say, knowing that just, of course, using your smartphone, you could access life-saving technologies whereby you can test for HIV, for COVID, or even for TB. Take me through this technology.
Good morning, Tumelo, and good morning to your viewers. Yes, so what we wanted to do was to provide diagnostic tools to people all over the country, basically. So whether you're in remote areas or you in peri-urban areas, you must be able to have a means of diagnosing what it is that you're suffering from. So we took lasers. You know, lasers are fascinating stuff. So they allow us to see through cells. So by shining a laser to a mammalian cell, you can actually be able to tell what exactly that cell has. If that cell is infected with a disease, you'll be able to tell. If that cell is about to divide, you'll be able to tell. So lasers allow us to sort of like get all intricate details about mammalian cells. So what we thought was, well, how about using lasers as diagnostics, and how about making it mobile enough that such that, you know, you can use it anywhere in the country or in the world. So we decided, you know, everybody owns a cell phone. Why don't put the technology on the cell phone? And that's exactly what we did. And we were so fascinated to see that our proof of concept experiments actually proved that the idea works. So now we are at the point where we are actually doing the final touches of the technology so that we can actually roll it out and have it as a fully fledged product.
Doc, I have to say, I'm equally excited and emotional because I'm so fascinated by what you're telling me, and also how it's filling in this big gap that we're seeing, because you're saying the target is everyone. It shouldn't only be to those who in a specific, you know, social class that can afford it, but if you're in the rural areas, you can afford it. If you have a smartphone, you can afford to use these tools. And I understand that from the technology, you need bodily fluids as samples, right? So this could either be your saliva, your urine, or your blood.
That's correct. So because I said, you know, the laser can tell you what's in a cell. In any bodily fluid, you get human cells. So if you take a sample of any body fluid, you will get cells or indicators in a form of biomarkers that will show you what it is that's in that particular sample. So you can use any bodily fluid. And because of that, the technology then allows to test for both communicable diseases and non-communicable diseases. So you're not only going to be able to test for your HIV, TB, COVID, and other communicable diseases, but you can also test for things like diabetes, you know, and indicators for hypertension, you know, various non-communicable diseases. So it makes the technology a multifunctional or a multi-screening device.
Yeah. Doc, did you walk a complex journey getting to this smartphone diagnostic tool? I mean, take me through how you and your team worked around the clock until you were confident enough to tell us about it, present it to, you know, the public as a solution to a whole lot of varying problems when it comes to detecting diseases.
Yeah, so the journey obviously is difficult, but if you've got a team of experts, so my team is actually multidisciplinary. You need to have a team that understands various aspects of the technology. So we are very good in understanding pathogens. So we know how microorganisms work, for example. We understand, because we've got virologists in the team, we understand optics very well. We've got a couple of laser physicists in the team, and then we understand the chemistry as well, because there's a lot of chemists in the team as well. So the fact that the team is multidisciplinary makes attending to technical parts of this technology very easy. So we know that in terms of the technical aspects, the team is sound. And then we've got a facility that allows for the kind of work that allows multidisciplinary experiments to be done. So the facility was also another enabler for us. I set up a fully functional facility that allows for biophotonics experiments to be done. So that made everything really very easy from the technical aspects. Of course, there are other aspects, including, getting partners, getting, industry to also partner with you and getting funding and all of that. I must acknowledge at this stage the Department of Science and Innovation. They really supported us. And we are here, we are really through their financial support and all the support that we got from the CSIR.
Well, I appreciate you, of course, speaking to us, Dr. Patience Mthunzi-Kufa from the Council for Scientific and Industrial Research. I mean, Dr. Patience, they being the research group leader for biophotonics, Dr. Patience Mthunzi-Kufa, and she's, of course, the research leader and the manufacturing cluster. So thank you so much for sharing more of this. I'm sure after this conversation, we should be seeing a lot of South Africans trying to research more and seeing how exactly they can have their smartphone, having this diagnostic tool, just so they can, of course, access it. So you can do so anywhere, of course, in any part of this country or this continent. Rural, township, urban areas, metros, wherever you are, it reaches everyone, everywhere in the country. Thank you so much, Dr. Patience.